Hello, today I'm going to talk about algebra basics. They are letters, numbers, number line, absolute value, using symbols, properties of exponents, properties of real numbers, and properties of equality and inequality. So let's start what we are understanding when we say algebra. So algebra means letters and numbers. So what is letters and numbers? So if we say 4 plus 1 equals 1 plus 4, we know that, right? It's easy. But we can express also this with a plus b or b plus a. So I use a and b instead of 1 and 4. So when we don't know what is the number, we put letters. So we call these letters variables. So this a and b are variables. Okay. So understanding algebra depends on how we know the numbers well. So let's talk about some numbers. So we have real numbers, some imaginary numbers, and complex numbers. In real numbers category, we have integers, natural numbers, whole numbers, rational numbers, and irrational numbers. Um, to understand this, let's talk about a little bit number line. So this is our number line. In this number line, when we go to this side, to the right, numbers gets bigger. And when we go to the left, number gets smaller. And 0 point is our origin. So this all real numbers and non-real numbers on the origin, on the number line actually. So let's try to understand what I mean by numbers, real numbers. So we said integers in this circle, in the yellow one, natural numbers, 1, 2, 3, 4, and it goes to the infinity. When we add 0 to these natural numbers, we will get whole numbers. When we include negative of these numbers, we will get integers. In the red part we can see red circle. And when we add fractions which are like 1/2 or -1/2 or 1.3, these are the fractions, and we said these are rational numbers. So what is rational number? On the numerator we have positive or negative integer. In the denominator we have non-zero integer. Let's say we have an example like 1/2 is fraction and it's a rational number. So we can write this fraction in decimal 0.5, right? These two numbers actually equal, but we can express it as a fraction or decimal. So these are rational numbers. What is the difference with rational number and irrational number? So irrational number, let's say we have pi. So pi is actually 3.1415926 and go on, and 3 dots. So these 3 dots never ends, right? And let me give you one more example, like square root of 2 is 1.4142136136. And so this 3 dots also never ends. Never ends. But in the rational numbers, so these are irrational. Irrational numbers. So if we can express it in integers, like fractions, it's irrational. For example, for rational number 1/3 is 0.333 and 3 dot. But this 3 dot is different from these irrational numbers because we can express this number here as a fraction like 1/3. So it's rational, but we cannot express them like something fractions. This is the difference. Okay, hopefully we get the idea. So let's talk about some absolute value. When we say absolute value, we will think distance. What distance? Like, let's say we are in the number line here in the 0, and this is number 3, and this is number -3. Okay, so from this -3 to the 0 and 3 to the 0, distance are same. So we say -3 in absolute value is equal to the +3. They all equal to 3. And it is always positive. Positive. So absolute value always comes out from positive numbers. Okay. So let's talk about some symbols and give some example about them. Okay. So the first symbol is less than. So 2 less than 3. In algebra, we will see like x less than 2 or y less than 3 or something like that. And second symbol is greater, like 4 greater than 3, or for x greater than y, or x greater than, I don't know, maybe 1. Okay, so third symbol is equal, like 2 equal 2, or x equal 3, or y equal, I don't know, 4 maybe. And it doesn't have to be x or y. When we can use a and other letters, like for example a equal 3. And not equal sign, 3 not equal 2, x not equal y, a not equal 4. Less than and less than or equal, so we can say 1 less than or equal 2. It's not equal, but it's less than, so we can write it like that. X less than or equal 3. What does it mean? X can be 3, can be 2, can be 1, or 0, or so on. So anything less than or equal. So we can include 3. Okay. Greater than or equal 3, greater than or equal 2. Y greater than equal 4. So this means y can be 4, 5, 6, so on. We can include 4. Okay, so there's something kind of hard for some people to remember. For here and less than and greater than, so this sharp point always points small value. Sharp end points small value. Yeah, keep it in mind. Okay, so let's talk about some exponents. So we can write numbers sometimes like exponent, like 2 to the 4. So 4 is exponent, 2 is base. So we can write 2 to the 4, actually 2 times 2 times 2 times 2. How many? 4. It's equal to 16. So we will use this sometimes. So what is the exponent's properties? So if two numbers base is equal, like a and a equal, but their exponent is different. Let's say 2 to the 3 multiplied 2 to the 2 is equal. So I will add them. 3 plus 2 is equal 2 to the 5. So we can also use x's, like x to the 3 multiply x to the 2 is equal x to 5. X or y or a, whatever the variables you are using. Okay, and division. So let me give example. 2 to the 3 over 2 to the 2 is equal 2 to the 3 minus 2, which is equal 2 to the 1, but we are writing only 2. Okay, let's give same example with x. So x 3 minus 2 equal x. Okay, so power of power. Okay, let's say 2 to the 2 power to the 3. So I will multiply 2 of them. 2 and 3 is equal. So when I'm multiplying, I'm using dot. It's easier. 2 to the 6. Same example with x. So x to the 6. Okay. So any letter or any number, if as exponent 0, like 2 to the 0 is equal 1, or x to the 0 equal 1, or a to the 0 equal 1. Okay, and if -1 or negative any numbers on the power exponent place, we will use 2 to the 1. Let's say we can write it 1 over 2, or x to the -1, 1 over x. It doesn't have to be -1. We can also say like a to the -3, also 1 over a, but we will use 3 exponent. Let's say 2 to the -5, 1 over 2 to the 5, x to the negative 2, let's say 1 over x to the 2. And we can use this property in different style, like let's say a over b, we have fraction to the negative power. So we should say b over a. We are switching places of the numerator and denominator to the 1. For example, 2 over 3, let's say we have a negative 3 power, 3 over 2 to the 3. Only switching the numerator and denominator and making power positive. Let's say we have x and y example. Negative 4 is equal y over x to the 4. Yeah, hopefully it's enough examples. So let's talk about some properties of real numbers. So we will talk about addition and multiplication. Okay, so addition is commutative, means x plus y. I can write y plus x. Actually, we know that, right? Like 3 plus 2, we can write 2 plus 3. So same property is for multiplication. X multiplied by y equals y multiplied by x. Let's check with numbers. 3 multiplied by 2 is equal to multiplied by 3. Actually, we know that, but with letters, sometimes it's confusing. To understand, you can use numbers. So addition and multiplication associative, what it means, we can write x plus y plus z, x plus parentheses y plus z. Same for multiplication, x multiplied by y, z, we can write it x, y in the parentheses and z in the outside. Okay. And they both have identity. So for addition, we have 0 identity. So we can write 0 plus x or x plus 0, all of them equal x. So 0 is identity. Identity in addition. So in multiplication, we have identity 1. So 1 multiplied by x equals x multiplied by 1. All of them equal x. So inverse. So in addition, is inverse is x plus x's inverse is negative x. So we can write it negative x plus x, and all of them equal 0. So when you add two one number with its inverse, you will get identity. Like this is inverse. So you will get identity. Similarly here in multiplication. In multiplication we have identity 1 over x. 1 over x equal 1. So 1 over x is identity. Sorry, inverse. It's inverse. Inverse. When you multiply by itself, you will get identity. Okay. And also, we have one more property, like negative. Multiply by negative x, you will get x. Similarly, when you divide by 1 over x, you will get x. And closure rule. So when you add two real numbers, you will get real number. Let's say z. So when you multiply two real number, you will get again real number. Let's say t. Okay, that's it for addition and multiplication properties. Let's a little bit talk about properties of equality and inequality. Okay, so if we say A equal B, then we can say B equal A. This is the first property. And second, if we say A equal B and B equal C, we know that. And then we can conclude A equal C. Similarly, here inequalities, if we know A less than B, and then we know B less than C, so we can conclude A less than C. Okay, and third, if A equal B and we use another number C, if we add C both of the side of equality, the equality will not change. Similarly, if you minus C in both sides, it will not change. Let me give an example with numbers so we can understand. Like if we know 2 equal 2, and then both of the sides, if I add 2 plus 3, and if I add here 3, like both of the sides I'm adding 3. Okay, so nothing changes. Equality is still equal. Okay, if we know A less than B, similarly if we add C on the both sides or minus C on the both sides, inequality doesn't change. Let me give an example. Let's say we know 1 less than 2. If I add 3 on the both sides, 1 plus 3 still less than 2 plus 3. Okay, and fourth and the last property is, and if we know A equal B, if we multiply both sides with C, nothing changes. Or if we divide both sides with C, but C is supposed to be not equal 0, because if it's equal 0, undefined. So equality doesn't change. In here, something a little bit confusing. If we know A less than B and we have C less than, bigger than 0, it means positive number. It means positive number. If we multiply both sides of the inequality, it doesn't change, still less than. And also if we divide both sides with C, still doesn't change. But if our C is less than 3, which means if it's negative number, this less than symbol is changing to the bigger. Okay. If I multiply both sides of the equation, I mean, it will change the side. Let me give an example. Let's say we have 2 less than 3 and we choose the C 4. So I'm choosing positive number. So when I multiply both sides with 4, my equation doesn't change. It's still less than. But if I choose C equal negative 4, my equation will change. 2 multiplied by negative 4 is bigger than, now it's bigger than 3 multiplied by negative 4. Why? It's this negative 8 and this is negative 12. And we know in the number line, let's say negative 8 here, negative 12 here. When we go to the left, it gets smaller, right? So negative 8 is bigger than negative 12. Yes, hopefully everything is clear. And then see you in the next video.